Question 11. In order to obtain CDI indications, course deviation indications, in the correct sense, very important is correct sense, in the correct sense, when tracking towards a VOR, you're tracking towards a VOR station on radial 235, what should the pilot set in his OBS selector? So you are expected to get normal sensing. First thing, you're tracking towards a VOR station. The second, and on what radial? On radial 235. So let's draw a VOR station. So this is your VOR station. This is your radial 235. Always draw the reciprocal as well. So the reciprocal of radial 235 will be radial 235 minus 180,055. Fine. Now you can follow this radial, which is radial 235, and you can go outbound from a VOR station. There are two possibilities. You can go outbound from a VOR station. In that case, if you are following this radial and flying outbound, you will have to select OBS setting of 235, and you will get a from indication and the needle in the center. If you are on the center line of this radial, the needle will remain in the center. If you put 235 OBS setting, you will get from indication, right? So this is what happens when you fly outbound from a VOR station. This is what the settings you should put. And this will give you normal sensing, meaning if the CDI goes to the left hand side, you go to the left. If the CDI goes to the right hand side, you turn your aircraft right. And this is done in order to get back on your radial that you have put in the OBS setting. Okay, so that is the point. The second possibility is you are flying on this radial 235 and you are going towards the VOR station. You are going towards the VOR station. In that case, what settings will you put? In that case, you will put 055 in your OBS selector. You will automatically get 2 indication, and if you are on the center line, the CDI needle will remain in the center. If you are on the center line of radial 235 flying inbound towards the VOR, these are the indications on your OBS selector. A setting of 055, the to and from flag showing 2 indication, and the CDI needle in the center, right? So your answer will be, what should pilot set on the OBS? The pilot should set 055 with 2 indication. The pilot should set 055 with 2 indication. Now when aircraft flies inbound towards the VOR, you will get 055 and 2. When it overflies the VOR, the to and from indication will start flickering. To from, to from, to from. After overflying VOR, this aeroplane will automatically transition from radial 235 on to radial 055. Okay, and when it comes on radial 055, it will fly in that direction. But now in this case, it will be flying away from the VOR station. Over here, it was flying towards. Now the same aeroplane is flying away from the VOR station on radial 055. So this OBS setting of 055 will remain the same. Like here, if aircraft is on the center line of that radial, the CDI will also stay in the center, and the to from indication will show from. From now on, the to and from flag will be from, because you are flying away from the VOR station on radial 055. So let's go to the next question. Question 12. A VOR is sighted at position A. Aircraft is sighted or located at position B. Now, VOR is at 35° north. Aircraft is at 34° north. So, VOR is directly to the north of your aircraft. Why directly? Because both longitudes are the same. That means VOR is directly to the north of your aircraft. Variation at VOR is 15° east. Variation at your aircraft is 20° east. So always, in case of VOR questions, you apply variations which is available at the VOR station. In case of NDB questions, you apply variation at aircraft. So let's draw this. This is your VOR. This is your northerly datum. Your aircraft, as given in the question, is to the south of VOR, direct south, not southwest, not southeast. Okay, and so direct south of VOR, that means radial. What will be that radial? That will be radial 180. Now this radial 180 will be true. Will be true. Okay. Now we all view our radials are magnetic in direction. So the next thing you will have to do is convert this true radial into corresponding magnetic radial. Now whenever you do this true and magnetic calculations, you require variation. You require variation. So if true direction is 180 and variation, now the variation you are going to use will be at alpha, that is at VOR, which is 15° east. So magnetic will be what? If variation is east, magnetic will be least, meaning magnetic will be less than the true direction. So less than true by what value? By a value of 15. So 180 minus 15 will be 165. 165. So aircraft is finally situated on radial 165. So option A is the correct option. Okay, simple. Let's go to next question. Question 13, often asked in the exam. The VOR is limited to 1 degree of accuracy. 1 degree at 250 nautical mile represents a width of what? So let's say this is your VOR. This is your radial, straight radial 360 or radial 000. Now the accuracy is 1 degree. That means if you are expected to get, if your expectation is radial 000, that means your aircraft is situated on radial 000, somewhere here. Okay, so the system should also show you that you are situated on radial 000 accurately. Okay, but it can happen, no system is perfect. So VOR, similarly as given in the question, the accuracy limit is 1 degree plus minus. So even though your aircraft is on radial 000, the VOR can tell you that you are on radial, that you are situated on radial, which is 001, or radial 359, or radial 359, which is minus 360 minus 1. Okay, so this is accuracy, the range, accuracy range, plus minus 1 degree. Okay, now the question is given that 1 degree at 250 nautical mile represents a width of what? So what you have to do is draw the VOR station. This is your original radial. Let's consider this to be your original radial of VOR. Another radial, an erroneous radial, which is at an angular distance of 1 degree. Now you have to find the width, that is the distance between these two. Your this radial, original radial, and the erroneous radial. Okay, so the width, that is the distance between these two, at what range? At a range of 200 nautical miles. At a range of 200 nautical miles. Correction, 250 nautical miles. So what you have to do is apply 1 in 60 rule. So what does 1 in 60 rule say? Track error or any kind of angular difference is equal to distance of track divided by distance gone into 60. Now this is your distance gone. This is your distance off track. Substitute the values. 1 degree equals to distance off track, we have to find out. Distance gone is 250 into 60. So distance off track equals to 250 divided by 60, which is equal to 4 nautical miles. 4 nautical miles. Okay. So the correct answer will be, it should be option Charlie. 4.4. Now what I have done is I have applied 1 in 60 rule formula. You can also use trigonometric formula and you can solve that. So we will do that as well. So in that case you have to apply tan theta, which is opposite upon hypotenuse, opposite upon adjacent, correction. So this is the opposite side of this angle and this side is the adjacent side. So substitute the value tan of 1 equals to opposite side, which is the width we have to find out. Adjacent side is 250. So width will be equal to 250 into tan 1. So tan 1 is what? Whatever, and multiply that 250. So you get that to be 4.36 nautical miles. Okay. So with 1 in 60 rule, you get 4.1. With tan theta, you get 4.36. So still the closest option is option Charlie, which is 4.4. Okay. Next, question 14. The VOR system is limited to 1 degree of accuracy. Same question, similar question. And you have to find the width at 3 nautical mile range, at a range of 300 nautical miles. So let's do this. This is your VOR. This is your original radial. This is your wrong radial. And now you have to calculate the width. So angle is 1 degree. The distance that you have traveled is 300. This is the distance off track that you have to calculate. Fine. So let's apply tan theta formula directly. Tan of 1 is distance off track upon distance gone, which is equal to x divided by 300. So the width which is asked in the question will be equal to 300 into tan of 1. So it is 5.2 nautical miles. 5.2 nautical miles. So correct option will be option A, 5.2. So very scoring, simple and scoring question. So don't get it wrong in the exams. Question 15. The two signals transmitted by a conventional VOR ground station are 180-degree out of phase on magnetic what? So like I said, in my previous video lecture, I explained in general the principle of operation of VOR, which is phase comparison, Meaning, if there is a VOR station in the center, and this is your north datum, we have one reference signal given out by the VOR, okay, one reference signal which is always oriented towards magnetic north, and another signal is variable signal which continuously rotates 360-degree around the VOR. Now this variable signal, let's say when it is here, okay, when it is over here, the angular difference between the reference signal and this variable signal will be what? It will be equal to 0, 9 or 0. It will be equal to 0, 9 or 0 degree. So phase comparison, the phase difference between your reference wave and your variable wave, right? Now if the difference between these two signals is 90 degree, that means we will call this radial 0, 9 or 0. Similarly, if when this variable signal rotates and rotates always clockwise, so when it comes down here at this point, let's say over here, so same thing, this is your variable signal. Now the phase difference or the angular difference between your reference wave and this variable signal will be how much? It will be 90 and plus 90. So it will be equal to 180 degree. So that means this signal is currently at a bearing of 180 from the reference signal. Okay, and we can call that as radial 180. Radial 180. Now when this variable signal rotates and goes on this side of the VOR, okay, on this side of the VOR, what will happen? The angular difference between the reference and this variable signal will be how much? It will be 270 degree, the phase difference. And therefore this radial will be called radial 270. So in this similar fashion, we get all other radials as well. And this is how we get all the 360-degree radials from the VOR, the difference between a reference signal and variable signal. Now in this question, we have been told that these two signals, what signals? They are talking about reference and variable. Now this reference and variable signals are out of phase at 180 degree. At 180 degree. Out of phase means what? When these two signals are away from each other. Okay, they are not coinciding. Now when this variable signal makes a full 360-degree rotation at some point over here, let's say here, at magnetic north direction, both this variable reference signal and the variable signal will coincide. That is the only one direction where both will meet with each other or coincide. Okay, and at this moment, or at this space or point of space, we call it both are in phase. In phase. That means both are coinciding. But apart from this one direction, any other angular change will be called as out of phase, as the signals being out of phase with each other. So starting from 1 degree to 359 degree, all these directions, at all these directions, the signals will be out of phase. Only at 360-degree direction or 000 degree, these two signals will be in phase. Now, if the question states that they are 180-degree out of phase with each other, means there is an angular difference of 180-degree between the reference wave and variable wave. So that is possible here. 180, right? Reference wave is this, variable signal is this. Okay, the angular difference between them is 180 degree, or phase difference is 180 degree. So what radial is that? That radial is radial 180. So the angle is nothing but your radial. Remember that. So correct option will be option delta, which is south. Radial 180. Radial 180. So let's go to next question. The two signals transmitted by a conventional VOR ground station are 270 degree out of phase. Now these two signals are 270 degree out of phase. So that will happen where? So see, this is your reference signal. This is your variable signal in the purple color. Now they are out of phase, meaning the reference signal and variable signal are not coinciding. They are separated by some angle, and they are out of phase by 270 degrees. So 270 degree is this, and therefore that will be called radial 270. And radial 270 is what direction? Westerly direction. So the correct option will be option A. The two signals will be 270 degree out of phase on magnetic west. Okay. Next, question 17. Which frequency band is used by VOR? Very simple question, frequently asked in exam. So VOR works in the frequency band of VHF. Okay, starting from 108 megahertz to 117.95 megahertz. Now, one important thing to note that is that now this is the total band 108 to 117.95. Out of this total frequency range, there is one band within it which starts from 108 to 112, approximately 112 megahertz. In this particular range, VOR shares its frequencies with ILS localizer, with ILS localizer. Okay, so it shares its frequencies with ILS localizer only between 108 to 112. Beyond 112, that is from 112 to 117.95, all the frequencies are exclusively available towards VOR. But between 108 and 112, the frequencies are shared between VOR and ILS. So how does that sharing happens? The frequencies with odd decimals, frequencies with odd decimals are meant for VO, are meant for localizer. Frequencies with even decimals are meant for VOR. Meaning what? For example, starting from 108, right? So for localizer, odd decimal. So 108 decimal 1, 108 decimal 3, 109 decimal 5, 110 decimal 7. So the decimals should be odd numbers. Okay, that those frequencies allotted to localizer. For VOR, even decimal. So 108 decimal 2, 109 decimal 4, 110 decimal 6, so on and so forth up to 112 megahertz approximately. The accurate value you must check in the Oxford book. Okay, so the frequency band is VHF, option Bravo. Remember this point. Frequently asked in YY exams, especially SPL, the VOR even decimals only between 108 and 112. Beyond 112, all the odd decimals as well as even decimals are for VOR. But in this range, the bifurcation has happened. So remember this for your YY exams and interviews. Next, question 18. Transmissions from VOR are may be adversely, that is negatively affected by what factor? Static interference, night effect, uneven propagation over ground surfaces, quadrantal error. So the correct option will be option Charlie. Static interference, night effect, and quadrantal error. These errors are the errors of NDV. Option Charlie, which is uneven propagation over irregular ground surfaces. That means if VOR station is surrounded by uneven topography, that is, there are mountains, plains, and all that, so the signal will have difficulty following a straight line path, okay, across this uneven topography, and therefore this propagation errors can be generated. So uneven propagation over irregular ground surface is the error of VOR. Other errors are for NDV. So let's go to question 19. If VOR bearing information is used beyond the published protection range, errors could be caused by what? Now, whenever you start flying for IFR, you will be tracking from one place to another using VORs. So let's say this is your position A, this is your position B, this is your position C. Now we do have RNAV, FMS, this advanced technological systems, but original navigation in the previous times when this technology wasn't available, we used to track by VOR, follow a VOR radial from one place to another, and then go to your destination. When you start flying in IFR, we basically do this. So now, if I want to go from A to B, B to C, A is a departure, C is your destination. Okay, the ultimate destination. This is your magnetic north direction, right? So now, first you have to go from A to B, the first leg, the first sector. So the approximate radial from A to B will be what? A to B will be, I'm taking it to be radial. Starting from A, this radial will be 0 to 0. Okay. And for Bravo, for this location, the same radial won't be 0 to 0. It will be the reverse of that, which is, for Bravo, this radial will be the reciprocal of 0 to 0, which is 180 plus 20, 200. Now, when you're tracking from A to B, there is a particular range beyond which you will have to transition to the next VOR station. Meaning, when you start from location A, when you start from location A, the frequency of this VOR location A, you will put in the frequency box. Let's say it is 108.4. So I have put that frequency. All right. There will be certain range designated. That is, this is called change over point. That means when you reach this point, you will change your frequency from this VOR A frequency to the next VOR, which is VOR B frequency. I'll draw it here. Okay, to VOR B frequency, let's consider VOR B frequency is 113 megahertz. Okay, so what happens when you are traveling from A? You take off from A, you will be following a radial of 0, 0, 2, 0 outbound. That's therefore you will get a from indication, and the needle will remain in the center so long as you are flying on the center line of this radial. At changeover point, at this very important point, you will change the frequencies from this VOR to that VOR. Why? You will get because at this changeover point is the maximum distance from VOR A, where you will get your transmissions accurately, right? Beyond this range, if you continue using VOR A, you won't get that transmission from VOR A. So that's why we have to switch to the next VOR. So at this changeover point, you change the frequency, and what will be your OBS setting right now? OBS setting will remain the same, which will be 020, but when you change to VOR B frequency, the from indication will become to indication, and the CDI needle will remain in the center provided you are in the center, you are on the center line of the radial. Okay, so this is the example. This is what I am showing for normal sensing. Okay, next, now when you land at B, you drop the passengers, take new passengers, new cargo. You take off from B again, and now you're heading for your destination Charlie. Now going from Bravo to Charlie, let's say this radial is radial 120. For Charlie, the same thing will be radial 300. Now when you go from Bravo to Charlie, again there will be a changeover point depicted on the chart, IFR chart, and when you reach that point, you change your frequencies. So starting from B, your settings will be what? You will first put the frequency of Bravo, which is 113. The OBS selection will be radial 120 put here. The to from indication will be from, since you are flying away from the VOR Bravo location. At this changeover point, what will happen? You will switch the frequencies from Bravo to Charlie. So let's say the Charlie frequency is something 115 megahertz. The OBS setting will be the same, 120, but what will change is the to from indication. From will become to in this case, because now you are flying towards the VOR Charlie, towards VOR C. Okay. So this is how navigation will happen when you travel from one VOR to another VOR. A, B, and C. So these changeover points are very important. Okay. The designated operational coverage. So it is also called published protection range. That is beyond this range, you will not get transmission from the previous VOR. You will have to change your frequencies to the next VOR. So errors could be caused by. So if you don't do this, okay, this published protection range will be depicted on the charts on the uh, whatever charts you are using, or the directory that you are using. In those resources, you will find this information, the maximum range for a particular VOR. And at that changeover point, if you don't change the frequency, what there will be an erroneous reading, and that will be caused by what? by interference from other transmitters, noise from precipitation static, sky wave interference. So the correct option will be option A. Interference from other transmitters. What happens is, at this changeover point, if you don't change from A frequency to B frequency, the transmissions from this VOR B will interfere with transmissions from VOR A. So up to this, in this region, in this particular region, VOR-A transmissions will be accurate. In this region, VOR-B transmissions will be accurate. Okay, so at this changeover point, you should change to VOR-B. If you don't do that, you will be getting erroneous indications, a mixture of VOR-A and VOR-B. So that is not wrong. Okay, in simple words, I am explaining. So you have to transition to VOR-B frequencies. So that is what happens. There is interference from two transmitters simultaneously. That is from VOR-A and VOR-B. So interference will happen. Okay, in order to avoid that, follow the changeover point procedure. That is change your frequencies. Diagrammatic wise, if this is your A, VOR-A, this is your B. You have something called like this. Okay, so this is the region for VOR-A in which you will use VOR-A frequency. Over here you will use VOR-B frequency. But at changeover point, that is where the maximum published protection range is published. So where there is overlapping here. Okay, here the interference will happen from both these transmitters simultaneously. Okay, so that's why when you transition from A to B, make sure you use B frequency, B to A, make sure you change to A frequency. So this will be caused by interference from other transmitters. Now this option B, which is noise from precipitation static, sky wave interference, these are the errors of NDB, not VOR. Next, question 20. Aircraft is 100 nautical miles from a VOR. Assuming no error when using a deviation indicator, one dot is equal to angular difference of 2 degrees. How many dots deviation from the center line of the instrument will represent the limits of the airway boundary? Now the airway is 10 nautical mile wide. What does this mean? This is your VOR station. This is the center line, okay, of that radial. Now the correct procedure will be to always follow the center line of the radial and go away from the VOR. But the airway, okay, the route in the air is wider than that. It is 10 nautical mile wide. That means 5 nautical mile this side and 5 nautical mile this side. Your job is to remain in the center, not left, not right. Although there is a space given, but the correct procedure is always to fly the center line of the radial. Right? So next thing they are telling you that you are 100 nautical mile from this particular VOR station. So you are 100 nautical mile from this VOR station. And they are telling you that you have to assume, just in case consider, that your aircraft has deviated from the center line of the instrument, from the center line of that airway to the airway boundary. Left or right doesn't matter. Let's consider right. So that means your aircraft has deviated from the center line to the right hand side, somewhere here, to the boundary of that airway. So we have to find out what will be that deviation, what will be the amount of deviation angular wise and dot wise. So let's join this triangle, make this triangle complete. Okay, so we know that this is 100, this is 5, right? Now let's find the angular difference between them. So using the tan theta formula, tan theta, which is opposite upon adjacent side, right? So opposite side is 5 degree, 5 nautical mile correction, and the adjacent is 100. Okay, so tan theta will be equal to 0.05. So theta will be equal to tan inverse 0.05. So shift tan inverse 0.05 will give you an angle of approximately 3 degrees. Approximately 3 degrees. So this is the 3-degree error. The error between this center line and this track, the airway boundary is 3 degrees. Now let's draw the OBS selector. We know it is this, and then it has a center dot, and there can be dots, 4 dots to its right hand side, 4 dots to its left hand side. Now when you're flying strictly on the center line of a radial, the CDI needle, the course deviation indicator needle, will remain in the center. Okay, if you have deviated left or right, accordingly the CDI needle will also deviate from this center line. Now over here we have assumed that we have deviated to the right hand side. Okay, so we have deviated right hand side. That means our original track is to our left hand side, this one. So the CDI needle will move towards the left, telling you that go left because your original track or planned track is to your left hand side. So let's erase this, and now it will go left. That is one thing for sure. Now by how many dots? Left hand side. Now one dot is equal to angular difference of 2 degree. Now we have an angular difference of how much? 3 degree. So 3 degree will be represented by how many dots? It will be represented by 1.5 dot. 1.5 dots. So it will, how will it look? It will look something like this. So the CDI needle will move 1.5 dots to the left hand side, telling pilot that go 1.5 dot left because the original track is to your left hand side. So this is the final answer. So how many dots? We have to find out the dots. How many dots? It is 1.5 dots left hand side. Also remember the side, left, right. Even though it's not asked in the questions, when you do this, find a solution to questions like this, always talk to yourself. What direction are you, have you drifted, deviated? What direction you have to follow to come back to your original planned track? So keep talking to yourself so that direction orientation gets us very good. Okay, all navigation is about direction, speed, distance, all that. So this basic element. So pay attention to that as well, even though it's not asked in the question. So this is how you do this sum. Question 20. With this, we have come to the end of this lecture, and I hope that you have understood all the solutions very well. I have explained everything with conceptual analysis also. So I hope if you have asked questions from this in the exam, very good. If you get asked questions similar to this, you know the technique of solving these questions as well. Okay, so all the best for your exams. And if you have liked this lecture, do hit the like button, subscribe to this channel, and share this video with all your friends.